Hi, my name is Andre. I'm 16 years old. I'm from SMK Manokwari and 11th grade students majoring in electronics engineering. So today I want to make an English assignment video, and in this video I'm required to practice the text procedure that I created in previous English class. The text must be themed to each student's major, so I thought why I'm not make a video that related to embedded system. So the goal or title on this video is how to control LED brightness using PWM on STM32. The material we use in this video is some LEDs, some STM32 breadboard, ST-Link, and some jumper wire. And the tools we need in this project is a laptop and then some STM32 Cube IDE as the software to programming and debugging process. So the first thing to do is just assemble the prepared component according to this schematic. So after you assemble all of the component, we can finally go to programming session. But before we program this STM32, we have to configure all of the peripheral pinout. So first thing you have to configure is this one. Just pick serial wire, and then on timer 2, clock source, you can pick this internal clock, and then on channel 2 you can generate PWM on channel 2. Okay, that's it. And then on configuration we can set the burst color to 7-1, and then on counter period or ARR you can set this to 100 -1. Okay, I think that's it. You can click this button to generate the configuration. Okay, then they will give you some empty code in this. First thing you have to do is in main program user code begin to, you have to start the PWM by adding this program. Wait, I forget it. No. How time PWM start. Okay. So in this function to start the PWM, you have to add these two parameter. The first one is which timer we want to generate the PWM, because in the previous session we choose the timer 2, so just add timer 2, and then on channel you can just time channel 2. Okay, don't forget this. And then on while you can use this function to set the CRR or capture compare register to set the data cycle. Yes, time set compare compare. But on this function, we're gonna set 3 parameters on this. The first one is same like previous, which timer we use on this. Time 2, and then channel 2, and then the value. You can manually set the value, but it will cost a lot of time, so we can copy this and then adding this logic or function to to automatically adding the value into the function. First step is on this function we can name the variable. I'll just name it e, and then the start value just 0, it's okay, and then the max value it's 100. Why 100? I'll explain it at the end of the video, but now let's just focus on programming. Then paste again. On this last parameter you can add variable e, so we will automatically adding, and then well, yeah, you understand. So yeah, we can add some delay on this. So okay, and then the second logic to will change this to 100, and then this one is to then 0, then this one is mine. Okay, so this first function is to adding value, and then second one is to subtract the value. It's basically just counting up and down on this loop, and then the value is adding to the function. Okay, I think that's it. You can upload the program, but first you have to plug the ST link, and then by clicking this bug icon you can debugging the STM32, and then just wait. Okay, if you on the debugging session or debugging mode, don't forget to click this button to start the program, or your program just gonna stuck and not going to make the loop. Okay, and then if you feel this value is to clicking so slow, wait. Okay, I think the program runs so slow, so we change the delay value, so this. Okay, then play it again. Start. Wait, what's wrong? Wait. Wait a second. I think there is some misunderstanding. Wait, playing so low. Wait. Okay, then run it again. Okay, so the delay is too slow, so we have to make it a little bit faster so we can see the blinking. So yeah, that's it. Next one is I'll show you the blinking on my phone. Okay. So now as you can see, this light is blinking, but it's little bit too fast, so we cannot see the brightness change. So I will make it little bit slow so we can see the brightness change. By increase the delay up to 10 millisecond and then running it. And of course you can manually change the brightness. By now I will change the brightness up to 50%. Wait. Because the ARR is 100, so we can more easy to add the duty cycle. I will give you the equation later at the end of the video and also explain it. So yes, now the brightness is 50%. If I change it to 10, so wait. Okay, you can see the difference. So yeah, I mean that's it. I think that's it. So this explanation part is not included in procedural text structure, so just consider this is a bonus. So before we start, I assume that you have basic knowledge of what PWM is and how we use it. So the explanation is going to limit it to setting up parameter. There are three main parameters that we use to generate the PWM in STM32. The first one is ERR, second one is per-scalar, and the third one is CRR. I recommend you to watch this great explanation about how these three parameters affect the PWM on this YouTube video. But in short explanation, the ERR determines the counter limit on timer. The per-scalar is used to define the frequency. And then the CRR determines the duty cycle on PWM. So why do we need to define and limit the frequency? Because the internal clock in STM32 is basically 8 MHz. We can use PWM with 8 MHz frequency, but for application like LED brightness control, 8 MHz is too high and our eyes cannot perceive the change. So, We need the frequency around 10 kilohertz to make it visible to human eyes. This is where these two parameter above work, is to divide the frequency to desired value. So if we follow this equation, first one is by dividing the frequency with ERR and then divide it again with per scalar, we can get this frequency around 10 kilohertz. But because the register in STM32 are already set to their values increased by 1, so we need to subtract 1 from the final value we want. Now that we have the desired value, it's time to determine the CRR value based on the data cycle using this formula. So for example, we want to generate PWM with data cycle around 50%. Then by using this formula, we can get the right value of CRR. And that's what I say, that since the ERR is set to 100, determining the data cycle becomes easier. So I think that's all. I apologize if there is any mistake in my explanation, and also because my pronouncing is very bad, so thank you for watching.